Hello everyone, I welcome you all to this video lecture on kinetics of particles. So far, we have discussed the motion analysis of particles without considering the forces. From this video, we are going to do the motion analysis of particles with considering forces. So we'll start from the DAlemberts principle. We know that the Newton's second law of motion is summation of F is equal to mass into acceleration. So we can rewrite this equation like this: summation of F minus ma is equal to 0. So this is the equation of DAlemberts principle. So here the m is the mass and a is the acceleration. So let me teach you the concept with a simple example. A block is placed on a rough horizontal surface. A force P is acting. So because of the force P, the block is moving to the right side direction. Okay, so here the block is not at the rest stage, the block is moving. So the same kind of illustration we have already seen in the static friction, but in static friction the body will be at the impending state, that is the body is about to move, but here the body is moving with some acceleration. In the problem, they will give you the acceleration value or they may ask you to calculate the value of acceleration. So that is how you have to identify the problems on kinetics of particles. Okay, so now the body is moving to the right side direction. So the body is not under equilibrium condition. So if the body is not under equilibrium condition, we cannot write the equilibrium equation. So this DAlembert principle is used to convert the body to equilibrium state. In the DAlemberts principle, an inertial force is applied in the opposite direction of the motion. The inertial force is ma. So the m is the mass of the block and a is the acceleration. So this inertial force will act in the opposite direction. So when we apply an inertial force in the opposite direction, now the body is under equilibrium state and we can write the equilibrium equations, that is summation of horizontal forces and summation of vertical forces. When we write the summation of horizontal forces, we have to consider the inertial force also. For example, the body is moving in the horizontal direction. So when we write the summation of horizontal forces, it is summation of h minus ma is equal to 0. And the body is under static equilibrium in the vertical direction. So there is no inertial force in the vertical direction. Okay. So this is how we have to bring a dynamic body into a equilibrium state. The first problem is a block of mass 100 kg rests on a horizontal plane as shown in figure. Find the magnitude of force P required to move the block at an acceleration of 2 meter per second square towards right. Take the coefficient of friction between the block and surface is 0.25. So here the acceleration is given and the body is moving to the right side direction. So this is a kinetics problem. So the body is moving to the right hand side direction and we know that when the body is moving towards right, then the inertial force will be acting in the opposite direction, ma. Okay, the coefficient of friction is given, that is mu is equal to 0.25. We have to find out P required to move the block at an acceleration of 2 meter per second square. So let us draw the free body diagram first. Okay, the block has a weight of 10 kg. So the weight will be acting in the downward direction. It is given in kg, so it is 10 into 9.81. Then the P is acting with some inclination. Let us resolve this into two components. One is P cos theta and the another one is P sin theta. Because of the friction between these two contact surfaces, a normal reaction will be there and this normal reaction will be acting in the perpendicular direction of the contact surface. Since the body is moving to the right side direction, the frictional force Fs will be acting towards left side direction. Now the important point is we have to consider the inertial force MA that is acting towards left side direction, MA. Okay, so now let us write the summation of horizontal forces is equal to 0. The Fs is acting towards left hand side direction, so it is minus Fs. P cos theta is acting towards right side direction, so it is plus P cos, the theta value is 30 degree, so 30 degree. The MA is acting towards negative direction, so minus MA is equal to 0. We know that the Fs is mu into Rn, so mu value is given, so it is 0.25 into Rn plus P cos 30 minus the mass is given, that is 10 kg, it is 10 into acceleration 2 is equal to 0. So if you rewrite this equation, you will get minus 0.25 Rn plus 0.866 P is equal to 20. Keep this as equation number 1. Then the second condition is summation of vertical forces is equal to 0. The weight is acting in the downward direction, so it is minus 10 into 9.81. The P sine theta is acting in the downward direction, so minus P sine 30 degree. And Rn is acting in the upward direction, so it is plus Rn is equal to 0. If you rewrite this equation, then you will get minus 0.5 P plus Rn is equal to 98.1. Keep this as equation number 2. So if you solve these two equations, then you will get the P value, that is P is equal to 60 Newton. So the important point about this problem is the body is moving towards right side direction. That is why we have considered the inertial force acting towards left side direction, and in the horizontal I have considered the inertial force. Then the second problem is two blocks of weight 1000 Newton and 2000 Newton are connected by a string and they move along a horizontal plane under the action of a force 3000 Newton applied as shown in figure. The coefficient of friction between the plane and the blocks is 0.25. Mu is equal to 0.25. Determine the acceleration of the blocks and the tension in the strings. So we have to calculate A and the T. We know that the tension is same throughout the length of the string. Okay. So first let us consider the 2000 Newton block. So we'll draw the free body diagram. The weight 2000 Newton is acting in the downward direction. The tension T is acting towards right side direction. Because of the friction between these two surfaces, there will be a normal reaction. Let us consider it as Rn1, and the frictional force Fs1 is acting towards left side direction. Because of the 3000 Newton acting towards right side direction, so these two blocks are moving towards right side direction. So this is the direction of motion. So if the direction of motion is towards right, then the inertia force will be acting towards left hand side direction. MA is acting towards left hand side direction. So now we'll write the equilibrium equations. We'll start from summation of vertical forces is equal to 0. It is minus 2000 plus Rn1 is equal to 0. We will get Rn1 is equal to 2000 Newton. Then summation of horizontal forces is equal to 0. The T is acting towards right side, so it is plus T minus Fs1, then minus MA is equal to 0. So we'll substitute the value of Fs1 and MA. It is T minus 0.25 Rn1 minus the mass value. So here actually the weight is given 2000 Newton. So it is 2000 divided by 9.81 because we have to substitute the value of mass into A is equal to 0. So if you rewrite this equation and substitute the value of Rn, then we will get T minus 203.87 A is equal to 500. Keep this as equation number 1. Then consider the 4000 Newton block. So we'll draw the free body diagram. The weight 4000 Newton is acting in the downward direction. A 3000 Newton is acting towards right side. And sorry, it is 3000 Newton. And a tension is acting towards left side. Because of the friction between these two contact surfaces, a normal reaction will be there. This is Rn2. Since the body is moving towards right, the frictional force will be acting in the opposite direction, that is left side direction. Consider this as Fs2. So now we'll write the equilibrium equations. First, summation of vertical forces is equal to 0. The 4000 is acting in the downward direction, so minus 4000 plus Rn2 is equal to 0. Further, Rn2 is equal to 4000 Newton. So in this block, since the block is moving towards right side direction, the inertial force M2A is acting in the opposite direction, that is left side direction. So we'll write the summation of horizontal forces. The T is acting in the left side direction, so it is minus T, and 3000 is acting towards right side direction, plus 3000, then minus Fs2 and minus M2A is equal to 0. We can substitute the value of Fs2, it is minus T plus 3000. The Fs2 is mu into Rn2, so mu is 0.25 and Rn2 we have already calculated, it is 4000 minus M2. So this is the mass of block 2, that is 4000 divided by 9.81 into A is equal to 0. So if you solve this equation, you will get minus T minus 407.75 A is equal to minus 2000. Keep this as equation number 2. So now, if you solve these two equations, then you will get the value for tension and acceleration. The calculated tension value is T is equal to 1000 Newton and acceleration is 2.45 meter per second square. Okay. So the problem is same like the frictional problems, but the only thing we have to add the inertial force, and this inertial force will always act in the opposite direction of motion. That's all. Thank you.